Hello everyone. Today's joke of the day is why couldn't the flower ride its bike? Stay tuned to find out. Our learning target for today is I can solve a system of equations using the elimination method. So remember, the goal of the elimination method is to eliminate one of the variables by adding or subtracting the equations together. Now, today we're going to learn about a new step in the elimination method because sometimes in order to use the elimination method, you need to multiply one or both of the equations by a constant or just a number to get the same coefficient or the same coefficient with the opposite sign in front of one of the variables before you can eliminate them. Okay, so let's look at an example here. For this system here, we have 20x plus 7y equals negative 29, and negative 10x minus 5y equals 25. Now, if we just added these equations together, neither of our variables would be eliminated because 20x minus 10x would give us 10x, and 7y minus 5y would give us 2y. So we would still have both of our variables, which would mean that we would be unable to solve for one of them. Okay, so we need to get rid of one of them. And if we look here, we can see that 20x is just 2 times the coefficient here of 10, right? If we took 10 times 2, it would give us 20. So what we want to do is we want to manipulate the second equation by multiplying everything by a factor of 2, okay, by the constant 2, so that we will be then able to eliminate the variable. And because we are doing multiplying each term in the equation by the 2, we're not actually changing the equation and the way that the variables relate to each other. So that's why we can do this. Okay, so let's rewrite our new system now that we multiply by 2. So this first equation will stay exactly the same. So we'll have 20x plus 7y equals negative 29. And then this we'll multiply everything by 2. So we'll take 2 times negative 10x will give us negative 20x. 2 times negative 5y will give us negative 10y. And then that will be equal to 2 times 25, which is 50. Okay, and now if we took 20x plus a negative 20x and we added these equations together, my x's are going to cancel out. Okay, and then we'll get 7y minus 10y will be a negative 3y is equal to negative 29 plus 50 gives us a positive 21. And then we can solve to get y by itself by dividing by negative 3 on both sides. So y is equal to negative 7. Okay? And then once we find that y is equal to negative 7, we can substitute negative 7 back into one of our equations for y, and then solve to find x. So in this case, I am going to substitute that negative 7 back into my second equation here. So let's change my color here. We'll have negative 10x minus 5 times negative 7 equals 25. Negative 10x, negative 5 times negative 7 gives us a positive 35, and that's equal to 25 still. And then we'll solve for x. Subtract 35 on both sides. Okay, those will cancel. We'll get negative 10x is equal to 25 minus 35 gives us negative 10. And then we divide by negative 10 on both sides. So x is going to be equal to 1. So our solution is going to be the ordered pair. Remember, our x coordinate always comes first, so it'll be 1, negative 7. And that will be our solution here. Okay, let's look at this next example. In this case, now we have a 6x plus y equals negative 20 and negative 10x plus 8y equals 18. And actually, this should be a 6y, not an 8y. Okay, so here, if we look at that 6x and that negative 10x, there's not some, in order to be able to eliminate those variables, we'd have to multiply both equations by something, and that wouldn't be the easiest solution here. So let's look at that y and that 6y. This is really a 1y. Okay, so we have that invisible 1 as our coefficient here in front of the y. And if we multiply that top equation by 6, or actually maybe let's do multiply by negative 6, so then they'll be opposites, then we will easily be able to eliminate, add the equations together and eliminate that y variable. Okay, so we'll take negative 6 times 6x gives us negative 36x. Negative 6 times 1y is negative 6y. And that'll be equal to negative 6 times negative 20, which is 120. And then we'll just rewrite our bottom equation. Negative 10x plus 6y equals 18. Okay, and we can add these together because that will allow us to cancel out our y's. And then we take negative 36x minus 10x will give us negative 46x. And that will be equal to 120 plus 18, which is 138. And then to get x by itself, our last step is to divide by negative 46 on both sides. So x is equal to 138 divided by negative 46. Let me get out my calculator here. That would be a negative 3. So x is equal to negative 3. Okay, and then I can substitute that back into my original equation. Let's take that original top equation. So we'll take 6 times negative 3 is equal to y, or actually plus y. Plus y is equal to negative 20. Okay. And then we just need to solve for y, simplify and solve for y. So we take 6 times negative 3 is negative 18 plus y equals negative 20. And then we want to add 18 to both sides to cancel out that. So we'll be left with y is equal to negative 20 plus 18 is negative 2. So our solution, written as an ordered pair, will be negative 3, negative 2. Okay. Now sometimes when you have equations that you're trying to solve by elimination, you might have to multiply both equations by a number in order to be able to solve. Because, for example, in this equation, in this system here, we have 5x and 3x, and those aren't going to be able to cancel if you just multiply one of them by something. And we have negative 3y and positive 2y, and those also are not going to be able to cancel by just multiplying one equation by a number. Okay, so let's think about what number negative 3 and 2 both would be factors of. Okay, and that number, if we took 3 times 2, that would give us 6. Okay, and we can manipulate each of these equations so that we have a 6 in front of the y. Okay, so in order to change negative 3 into a 6, we'd multiply the whole thing by 2. This is really similar to finding like a common denominator if we were to add fractions together or something. Okay, it's not that much different. We're trying to find the least common multiple. So we multiply that top equation by 2, and we multiply this bottom equation by 3 to get our new equations. 2 times 5x is 10x, minus 2 times 3y is negative 6y, is equal to 2 times negative 1, which is negative 2. And then we have 3 times 3x is 9x, and 3 times 2y is plus 6y equals 3 times 7, which is 21. Okay, and now we can add these equations together to cancel out our y's. And then 10x plus 9x will be 19x, and that is equal to then negative 2 plus 21 is 19. We'll divide by 19 on both sides, get that x is equal to 1. And then if x is equal to 1, we can substitute that back in. Let's look into our bottom equation here. We'll take 3 times 1 plus 2y equals 7. And then we'll just have to solve for y. So 3 plus 2y equals 7. Subtract 3 on both sides. 2y is equal to 4. And then divide by 2 on both sides to get that y is equal to 2. And our solution is the point 1, 2. Okay, now there are a couple special cases that I want us to look at and see what might happen with. Okay, so for this first one here, 16x and negative 4x, we can multiply 4 times 4 to give us a 16. So let's multiply this bottom equation by 4. We'll rewrite both of our equations. We get 16x minus 12y equals 8. And 4 times negative 4x is negative 16x. And 4 times 3 is a 12y is equal to 4 times negative 2, which is 8. Or negative 8, actually. Okay, if we add these equations together, that would be how we could cancel out the x's. But also, let's look at this. We would have negative 12y plus 12y, which should cancel those out. So really we'll be left with 0 on the left-hand side here, is equal to, well, 8 plus a negative 8, which is also 0. Now, this is our special case where 0 is equal to 0, and that happens always, right? There's no time when 0 would be not equal to 0. That means that no matter what numbers we substitute in for x and for y, our system will always have a solution, okay? And so that means there are going to be infinitely many solutions for this case. In fact, these two equations represent the same line. So like if we were to graph them again, these two equations would just be the exact same line, which is our case where we have infinitely many solutions. Okay, so if this is a true statement, 0 is in fact equal to 0, then we know that there are infinitely many solutions. Okay, now our other case would be one like this, where now if we had negative 16 plus 20y equals negative 4, and negative 8x plus 10y equals negative 4, we could multiply this bottom equation times, let's say times a negative 2 to get us to that similar coefficients. So we'll get negative 16x plus 20y equals negative 4, and we'll get then 16x negative 2 times a positive 10 is negative 20y equals negative 2 times negative 4 is a positive 8. Now in this case, when we add these equations together, our x's will cancel and our y's will cancel, so we'll be left with 0 is equal to negative 4 plus 8, which is 4. Now this is not a true statement, right? There will be no times that 0 would be equal to 4. That means that for any x values or y values that we plug into these systems, they will never be a solution, meaning that these lines are going to be parallel and they will never cross. So in this case, there is no solution because there is not a true statement. Okay, if there's ever the case that it's not a true statement, that would mean that there is no solution. Okay, so for today's joke of the day, why couldn't the flower ride its bike? Because it lost its pedals. Thanks for watching and have a great day.